All right, so what I'm going to do is I'm going to, let me see if I can drop it and follow along here. So our first dividend 1. So in solving using the net present value, this is going to give me the stock valuation for stock C in number 18. And I'm going to use the 10%. So let's see, how do we do it? Well, this, again, these are cash flows, right? The dividend. So first cash flow, I'm going to pull out my CF, see what's in there. Lo and behold, I have it in there. Let me clear it out. Okay, so let's see here. Good. So CF0, there is no upfront cost in using this NPV calculation of these cash flows right here. Okay, so let me lift this up just a little bit and use this right here. Okay, and I combined the year 6 calculations, 1244, and the horizon price of 124.42. Okay, so there is no, in other words, what I'm going to do is enter beginning right here in year 1. Okay, there is no upfront cost that we're putting in. We're just looking at an investment right here that's paying out dividends over the long haul, right? For 6 years at least and more, given the horizon price. So 5, what am I doing? So in this case, the first thing I would do is enter CF and put a 0, enter, and then drop down C1. Okay, cash flow 1 is going to be $5. Enter, happens one time. And I'm kind of anal about that, but I put in the 1. C2, $6. Okay, if you want, you can see up here how I did the calculations. Okay, right there. And when I'm entering this, let's see. So in year 2, I've got a dividend of $6. 00, and I'm going to enter that, and that happens once. Enter, and then $7.20 per share of dividend. Enter. Okay, that happens once. Enter, and I push the CF button. Okay, $8.64 for my year 4 cash flow. Okay, one time it happens. And $10.37. Enter. One time. Enter. Oops, jumped a little bit there. Let's see, what was my year 5? Year 5 was 1037, right? Now, you could enter them separately. Doesn't matter. Or you could combine them. I combine them. So I took 1244, which is the dividend in year 6, plus the horizon price of 124.42. Okay, is 136.86. So when I drop down, this happens one time. Okay, one time. Enter in year 5. Then year 6 is this would be 136.86. Enter, down, 1, enter, down, and then we stop at year 7, okay, because we've already brought in the horizon price and basically brought it in, representing everything from year 7 on out at a constant growth rate of 0, or whatever the case may be in other problems, which is G2, and we brought it into 0.6. So now I know I can go over to NPV, and our discount rate that we're using is 10%. So I put in 10, enter, drop down, and it says compute. So I'm going to compute. Okay, and for 10%, I get a price of $104.50. Okay, or 51 cents. So 104.50769. So that's how I got this one right here. Okay. Again, for the 7%, I'm repeating myself, but I got $156 and 50 cents for stock C. Okay, I knew I would get a larger number since I had a smaller market cap. Okay, into number 20, the two-stage model. Okay, number 20 says company Q's current return on equity is 14%. It pays out, all right, 1/2 of its earnings is cash dividend. The payout ratio equals 50%. Payout plus retention or plowback ratio equals 1. Current book value per share is $50, okay? And that comes from the balance sheet on the equity side and down into a per share basis. Book value per share will grow as we reinvest in earnings, okay? As Q reinvests in earnings. Assume that the return on equity and payout ratios stay constant for the next 4 years, okay? That's one stage. After that, the competition forces return on equity down to 11.5. And the payout ratio, dividend payout ratio, increases to 0.8, which would leave the retention ratio at 0.2. Okay, the cost of capital, okay, or the cost of equity capital, cost of opportunity capital, opportunity cost of capital, or the discount rate, whatever you want to call it, is 11.5, okay? So the question asks, what are Q's earnings per share and dividends per share next year, okay? That's EPS 1 and D1. How will EPS and dividends grow in years 2, 3, 4, 5, and 6 in current subsequent years? B, what is Q's stock worth per share? So that's basically what is Q's stock worth per share at time 0, its present value. How does that value depend on the change or the beginning and ending payout ratio and growth rate after year 4, actually the ending? Okay, so you're going to have 2 payout ratios and 2 growth rates. So in this problem, I'm going to show you this strategy that I used, and then we'll kind of take it from there. I laid out the givens, and then went from there, okay? Laid out the dividends. I know it's a 2-stage model. There's only a couple things you have to solve up front. It looks complicated. It is not. With that said, what I did was, and here you can also use your calculator. It will come in handy. So the strategy that I follow, and this is actually the back side of the problem. The strategy that I follow is, and maybe you can do this with solutions. I mean, it's up to you. hopefully this is of help to you. So basically what I'm doing is I'm saying, well, the very first thing we want to say is when do we use earnings per share versus dividends? That's that link they're talking about between the stock price and the earnings per share in the PowerPoint. So we use earnings per share when there are no dividends available, okay? Sometimes we can get the dividends, sometimes we can't. If we can't, we tend to go to the net present value of growth opportunity model, okay? Using those value of current assets plus all future growth or present value of future growth investments or growth opportunities. So in this problem, in number 20, I put down the givens, all right? And remembering that, in essence, I have 2 ROEs, okay? And I'm looking at this real quick. The strategy that I'm going to follow, I'll just give you a quick heads up, all right? I put the givens down. And in this case, what I'm going to go after, given that ROE, original or current, is 14%, payout ratio current is 0.5%, which means retention is 0.5. The book value of equity per share is $50 per share. Book value will grow as reinvestment earnings grow. Why? And when I discuss this, this is really, remember that book value equity equals earnings per share over return on equity. So if I need EPS, I just rearrange it, right? And so as earnings increases, as earnings per share increases, it also increases the book value equity. All right, and that shows up on the balance, on the equity side, on the balance sheet. When we do this, I can turn around and solve for ROE. All right, and of course, years, as they talk about years 1 through 4, that's a clue that we're going to be doing this in stages. So, and we're given the opportunity cost of capital of 11.5%. So a couple of things that we're going to be looking for first and want to solve for first is we're going to want to get our earnings per share 1, and that will allow us to get the dividends per share, okay? And then in question A, it says, how will they grow over years 2, 3, 4, and 5 and beyond? And I'm sorry, this isn't a strategy just yet, but it is and it isn't. And the B is what is the present value of the stock, and lastly, how does the payout and the growth rate affect the present value, and you could also say the horizon value of the stock. Okay. And when we do that, let me go over. Now here's my strategy, okay? My strategy first is to get earnings per share at times 0, dividends per share at times 0, and we also need the retention ratio at years 1 through 4, which we have. It's 0.5. I'm sorry, yeah, it is 0.5. And then in year 5 and beyond. So we need a timeline. It would be really helpful. So again, I've got the growth rate. We also will need that for years 1 through 4. Growth rate for years 5 and beyond, up to infinity. So this is, again, a 2-stage model, as we can tell. So what are we given? That's one of the things I'm going to be looking at. And again, let me separate this. And I'm going to go straight into it. Number 20, continued. Okay. Basically what we're given is that the payout ratio was 0.50, right? We were given that. Yes, payout ratio is 0.50. So payout plus retention equals 1, right? Okay, take a drink of water here. So what I end up with, one of the very first things I do, I solve for the retention ratio and then put it into the famous formula for the growth rate of dividends, which is plowback, okay, or retention ratio times ROE1, okay? In this case, that would be 0.5 times 0.14 equals 7%, all right, for G1. G2, it's a little different story. G2 is going to be 1 minus that 0.8, and that 0.8, I believe, looking back, the 0.8 was a payout ratio increases to 0.8 from 0.5. So that would leave me a retention ratio or a plowback ratio of 0.2. And we have a new ROE of ROE2, okay, of 11.5%. And that will give me G2, okay, which is equal to, and that's going to be for years beyond year 4, okay, years 5 and beyond, of a growth rate of 0.023 in any dividends or earnings that we use, we can assume, okay? The other thing that we're given is a $50 book value per share, book value of equity per share. So we need to be able to rearrange that to acquire earnings per share times 0. Okay? And when we do that, we're going to get ROE at time 1. So we're going to solve for that years 1 through 4, basically, of earnings per share and dividends. We basically solve for earnings per share and dividends, and we're going to do it for years 1 through 4, and then for year 5, because at year 5, it becomes a constant growth rate of 0.023. Okay? That's at G2. And we can use that and apply it on the earnings per share and on the dividends per share. And then the next set or step is we will solve for the horizon value, okay? And then after we do that, we can discount everything back, including the dividends that we've calculated right here. And we will end up with everything solved right here, okay? And you'll notice that in years, we get to year 4, everything levels out to a growth ratio of 2 of 0.023, okay? So I'm going to solve for pH first, all right? Obviously, I'm going to solve for the EPS 0 first, and that's what I highlighted. That ends up being $7.14 times $50 per share. I rearranged that ratio right here. And then I get, that allows me to get the dividend, which is basically the payout ratio times the earnings per share. And I can use that on each one of my dividends. So that will allow me to get 0.5 times 7.0 per share, gives me 3.5 per share. So I've got EPS 0 of $7, dividend 0 of $3.50 per share. Okay? And then from there, I can calculate everything out. The only thing different that might throw you, if at all, I doubt this would throw you, is that you're going to end up with $9.18. Once you get into year 4, you've got a $7 earnings per share, right? Times 1.07 to the 4th, okay? And 7%, that is G1, the G1 growth rate. That's going to give me about $9.18. That $9.18, I'm going to move over here. That will be basically dividend in year 4, okay? Times 1 plus, that would be, that's going to be dividend in year 4. And then I'm going to take the new growth rate, okay? So in actuality, I could have moved this entire thing up here and gotten, I was confusing dividends with earnings. So we've got the earnings per share of $9.18 times our new growth rate, G2, okay? And 19, so the earnings per share would turn into a final, and this would be $9 and $9.38661, or $9.39 for earnings per share in year 5, which translates into, just as we did with the first dividends, which translates into the basically the payout ratio times earnings per share. So I get an earnings per share of 9.39 times, originally it was 0.5, the payout ratio. Now it's changed to 0.8. Okay. So I could take $9.39 times 0.8, and that gives me a dividend in year 5 of $7.51. Okay. So once I have dividend 5 and EPS 5, I know I can make my move and use dividends, use all the dividends that are calculated here, not exactly linear or vertical per se, right there, and dividend 5 right there. So year 0, 1, 2, 3, 4, and 5. Okay, that's for the dividends. So now I'm going to plop this into the horizon value. I'm going to calculate that next, okay, which will be dividend 5 times 1 plus the new growth rate, R minus G2, okay? And again, we've got 751 for our new dividend times 1.023, and then we're using 11.5 as a new, as the market cap rate or discount rate, minus our new growth rate, which is, again, this is a perpetuity, representative of perpetuity of dividends paid out. And again, if I go back to where'd it go? As I go back, this is problem 20. And as I go back to this problem, let me see, it's going to be over here, I believe. Where did you go? Right here. As I drew the timeline out, okay, for number 20, remember that basically what you're doing is you're bringing in that dividend 5 times 1 plus G2, R minus G2. That gives you the horizon value. You bring it into where things start to level out in terms of growth. And at year 5 and beyond, it goes into a level growth rate of 0.023. Okay, so from there, it becomes basically a perpetuity. And again, this is the Gordon growth model. And this is representing the horizon model, the price of the stock in year 5. Okay, and so now, once I get it, I can bring it back in all the way into time 0. And so, again, that's why it helps to do the timeline and do your formula. So once I do and solve for the horizon value, okay, I end up with 7.6827 divided by 0.092, which gives me a horizon price of $83 and roughly 50 cents per share at time 5, year 5, okay? And that's basically representing future expected dividends, okay, at year 5. Okay, so, and a perpetuity of them at that. So when I flip it over, I'm going to put it into my final equation, all right? And these are long problems. They aren't complicated. And I would give you something like this on the test, but only one, believe me, because I have to correct them. So with this said, I'm going to put in D1, because I already have dividends calculated, right? Over here, right on this side, okay? Basically, which were derived from the earnings per share for each year, 1 through 5. And so when I do this, I come up with my final formula. You can keep these two separate. Okay, this is year 5. And this is the H. Okay, this is the horizon value. Okay, of the dividend, $83.50. Dividend in year 5 is $7.51, roughly. Okay, so I like to combine them because I know I'm going to put it in the calculator. And when I do, I will get, and when I put it in the calculator, I'm going to use the NPV function again. And let me see if I can move this up so you can see it all. Can you see that? Okay, yes you can. So when I'm doing that, I just thought it wasn't recording. I'm going to plop that in, and that should give me, and I'll clear this out because I know I've got information in there. Oops, wrong button. Okay, clear it out. And I would enter in CF, and for the NPV, since I'm going to be entering these cash flows, each one of these is representative of a cash flow, even though it's a dividend. And dividends are cash at times, right? And so 375 will be my dividend 1. There is no upfront cost for this NPV calculation. It's kind of a trick of the calculator, so to speak, that we use the calculator. So 375, okay, would be my first dividend. Okay, enter, happens once. You don't even have to press enter on that. And then 4.01 enter. Okay, happens once, enter, down. My third is $4.29. Okay, and that would be 4.29. Enter. Okay, I know I'm going to make a mistake. Enter. And fourth year, $4.59. Enter, down, enter, down. Okay, fifth year, I actually combined both of these, the horizon price and year 5 dividend. Okay, that is, gosh, no, I didn't actually. I did, but let's see what they came out to be. 83, what is that? Let me add that together. That would be 1, 0, 1. Okay, so that'd be a 0, 11, be a 9, 91.01, right? Okay. So in this case, when I combine these two, right, I'm not using the 2. In that case, let's see if we get the right one. Cash flow 5 would be 91.01. Enter. Okay. Cash flow 5 would be one time. Happens. And that's it. Now I know when I get to year 6, I'm way beyond. Okay. So when I do that, and I'm just looking at what I wrote here, let's flip over to the NPV and put in our discount rate, which is, or our market cap rate, or cost of capital, which is 11.5. You're going to enter it like that. And let's compute, see what we get. It's probably wrong. No, 65.46 or 46305. Okay. So I actually am off just a little bit, and I think it was in my addition here. I'm a little on tired. 65.45. Let me look at that one more time here. But I know that's correct. The P0 I get right here is 65.45 per share. Okay. And where do the solutions get? Just out of curiosity. 65.45. Or is it 46? Okay. So with that said, let me, I'm going to double check my math here. 90, what am I doing? $83.50, 83.50 plus 7.51 equals 9101. That was correct. So that's close enough for now. As long as you're close and you show your calculations, you're good. So that gives me the ability to be able to answer all questions for number 20. Okay, again, this is number 20. With that said, just be aware, be able to look at page page 96, okay, 95, I'm sorry, 96, 97, okay, and we need to be able to verify our horizon price, and you can do that by turning to comparables and using, just like when you compare housing prices, okay, and you're trying to find, okay, what should my house be priced? Well, we're kind of doing the same thing here, except what should my stock be priced at? Well, and at this point, you want to look at what should it be priced at in terms of out in the horizon when the growth in the stocks go constant. And then you bring it in and discount it. Okay, so you can actually check the horizon price by looking and replacing dividends with earnings per share. You could use market to book. You could use price to sales. There's a whole bunch of different things that you can replace it with. And basically what you're doing is using comparables that are with companies that have similar projects, similar growth potential, similar risk and scale and size. Okay, So with that, I think with number 23, you don't have to do it. You just have to watch the video on how Mr. Shuzik does number. He goes through a very simple problem for the net present value of growth opportunities, which comes from, what page is it? That is the link between stock prices and earnings per share. And he goes through a much easier to understand example. If you could, Stuart Living, if you could understand that one, please, or look at it. And number 26 in our book, which is just taking the free cash flows, okay? Which is just basically the difference between, we're looking at, I believe we use table 4.7, is it? Table 4.7, which is just taking the difference between the earnings and the investments. And these are all assumed, okay? And we take the cash flows or free cash flows. And free cash flows, again, is just cash flows from assets, okay? The cash flow that we make off using our assets. And in this case, what we're doing is doing a very, very similar problem. It's almost like a two-stage discounted cash flow problem. Except in this case, we are using free cash flows, and we do calculate a, it's very similar to what's set up on, where we go, on page 96. Okay, so we're looking at, let me show you right here real quick. Okay, very similar to the dividend setup. Okay, so we have our first stage, then we have the stage where free cash flows start to grow at a constant rate or a zero rate. All right. So with that said, then you just combine you take the present value of each cash flow, you sum them, okay, the basis of stock valuation, as we do it here in this chapter. And you also combined the horizon price using free cash flow, okay? And this happens to be free cash flow looking at from period 6 and beyond, okay, forward. So again, that's this is the Gordon growth model or a growing perpetuity. And the reason you grab 1.09 in this example on page 95, which is just like problem 26, is basically that you want to use the dividend, and it's not dividend, it's the free cash flow of the following period, okay? And then you want to take that horizon price and bring it back into time zero along with the rest of the free cash flows, okay? And in this case, I spell it out in the number 26. I give you guys the solution via video, okay? So that should be it. Have a great night, and I'll be preparing your tests. Take care.